geometry students. Today in lesson 2, we're going to be introducing some of the foundational concepts of geometry. And so everything more or less builds on the 4 postulates that we're going to introduce today. And so number 1, what is the essential question? What should you be able to answer here at the end of this lesson? Well, what is a postulate? So that's kind of the big enduring thing that you need to understand. And then the learning target, what are you going to be tested on? Well, you need to be able to identify different ways to see points, lines, and planes. So points, lines, and planes, what you got to know for today. All right, so some vocabulary and then some postulates. So number 1, what is a point? Well, a point has 0 dimensions. You've heard of the first, the second, and the third, maybe even the 4th dimension, but a point has 0 dimensions. You cannot measure a point. A point is just a point. Usually we indicate a point with a capital letter, and so that's what it'll look like. A line, there's different ways to do lines, but a line is simply a one-dimensional figure, and technically we put arrows on both ends, indicating that it goes on forever and ever and ever. We have line segments, we have rays, those are all a little bit different, but a line goes on forever and ever. And so the way that we would indicate that would be maybe with like AB, if we had points A and B that this line went through, and there you go. A plane is a 2-dimensional figure. And I guess one thing that students need to know about a plane is, I have, if I'm going to draw a plane, I kind of have to put limits on it. But what's actually happening here is this is a shape that's going infinitely up, down, left, and right. So this isn't the plane just like of a square. It's a plane that would encompass the board or the wall, and you're going on infinity in each direction. So it's flat. It's not actually contained, but in order to draw it, we kind of have to draw those shapes. And usually, we'll just say maybe plane Q in lowercase there. All right, 2 other things that you need to know here. Collinear. So collinear, points are collinear. Points in the same line. And so, like up there in our example for line AB, AB would be collinear points. They're in the same line. And so if collinear means in the same line, you can probably guess what coplanar means. Coplanar just means in the same plane. And you can have lines that are coplanar, and you can also have points that are coplanar. All right, so the first 4 of Euclid's 5 postulates that really got this whole ball rolling with geometry. He made 5 basic assumptions that are so simple, and just so you know, a postulate is something that is so simple that it doesn't need to be proven. We just take it for granted that it's true. And so postulate 1 that Euclid had here is through any 2 points, there exists exactly 1 line. 2 points, if you got 2 points, between those 2 points there's only and only 1 line. Second postulate that he came up with, if 2 distinct lines intersect, then they intersect in exactly 1 point. And again, this should be pretty simple for you. You should be able to understand and think, all right, yeah, if I have 2 different lines, distinct lines, they're only going to cross in 1 spot. They can't cross in more than 1 spot unless they're not lines. The third one, if 2 planes intersect, okay, so imagine now 2-dimensional objects. These got these 2 planes, like 2 pieces of paper kind of. Then they intersect in exactly 1 line. So 2 planes intersect in 1 line, just like 2 lines intersect in 1 point. And then the fourth one, through any this, and we're just going to say through any plane there are there are at least 3 non-collinear points. Okay? So if you've got a plane, then that plane has to have at least 3 points. You can't have a plane with just 2 points because that would be a line. So you need 3 points to make a plane, and not only do you have to have 3 points, but they have to be non-collinear points, and that's kind of the thing that a lot of students forget. So if you had 3 points or 3 collinear points, well, that doesn't make a plane, that just makes another line. So what you need is 3 non-collinear points, and then you've got the makings of a 2-dimensional shape or a plane. All right, so how might you be asked? There's only one learning target today, and so how can I ask you to identify different points, lines, and planes? So a couple different ways here. We've got a diagram, and we're going to use that to answer these questions. What are 2 other ways to name AB? Well, you can see that AB is a line. We could, F is on that line, so we could say line AF. And as long as we're being meticulous, we'll put that arrow above it, although sometimes we get a little lazy and don't put it there. We could also call it BF. Right? We can choose any points on our line to identify it with. Sometimes we could even just say something like line F if we wanted to. That'd be okay. What are 2 ways to name plane Q? Well, we've already got plane Q, so now we could just say plane, and now we just have to pick 3 non-collinear points that are on that plane. So maybe ACE. Okay, that would work. A, C, and E are definitely not collinear. We could also say DA. So plane DA. Right, you can again see that DA and E, those are collinear. So maybe DAC. Okay? DA and C are non-collinear. All right. What are the names of 3 collinear points? Well, just any 3 points that are on the same line. EAD would be good. So EAD are 3 non-collinear points. And what are the names of 4 coplanar points? So these are points that have to be in the same plane. Well, let's see. 4 points that are in plane Q. E, A, D, and I guess I kind of wrote over it, but that's got to be A, E, C. Okay. So all 4 of those are in plane Q. Example 2. What is the intersection of plane A, E, and H? That would be the AEH, that would be the purple one, and plane EGH, that would be the blue one. Well, you do know that the intersection of any 2 planes is a line, and so in this case, the line here is EH. Not too crazy there. Example 3, each surface of the box, we just got a regular rectangle prism, is part of a plane. So obviously they're cut off because we know planes extend forever and ever, but which plane contains points J, M, and L? Well, here's J, here's M, and here's L. And so that would be that top plane there. We would just say, if we had these numbered, you might just say, here, we'll number it something official. We'll call it plane Q. Except we've got a Q. We'll just say it's plane A. We'll put little a there. So plane A. All right, let's see, and then which plane contains L, P, and Q? Well, L is right here, P is here, Q is here, that would be kind of this side one, we'll call that plane B, lowercase b, so we'll just say plane B. And that's how we would identify planes. Alright, well that's it. For lesson 2, there's your practice problems and your problem solving.